Chapter 7, Sets and Probabilities. So let's start with sets. Okay, set is a collection of numbers, letters, or anything. Okay, so for example, set A. Okay, we use capital letters and such brackets to indicate sets 2, 7, 0, -3, 5, 10. Okay, this is set. For example, I can write another ones, any number. So 5, 0, -9, x, 5, -1. Okay, and C, let's say 3, 5. Okay, here order doesn't matter. For example, if I have 5, 3, okay, 5, 3 and 3, 5, they consist of same elements. Therefore, they are equal to each other. Okay, for sets, order doesn't matter. You can write in any order. And we have this sign. Okay, it is belongs to or element of. Okay, this means belongs to or element of. For example, in A I have 7, so I can write 7 belongs to A. Or X is element of B. Okay, or I can write 3 is element of C. Then 9, is it element of A? Do we have 9 in A? No, so it is not element of A. Or 3 doesn't belong to B, because in B we don't have 3. Okay, this is one symbol. Okay, next, write the element. Another one, another symbol is N. NA. NA means number of elements of set A. So in set A, how many elements we have? 1, 2, 3, 4, 5, 6. So we have 6 elements. So NA is equal to 6. And B. In B we have 5 elements. And C is 2. And D also is 2. Okay? So we have these two signs. This means belongs to or element of. This means number of elements. Okay, indicates number of elements. The set consists of x elements, and x has following properties. X is a state whose name begins with letter O. So that is Ohio, Oklahoma, origin. Okay, I will show you another example. Okay, so here, let me show. Right, A consists of x elements. X is natural number. Natural number and less than 3. Okay, so this means A consists of x elements. X is natural and it is less or equal 3. That means it is equal to 1, 2, 3. Okay, here we have these 3 natural numbers which satisfy these 2 requirements. B consists of x elements. X is odd integer and it is between 13 and 7. So odd numbers: 1, 3, 5, 7, 9, 11, 13, 15. That one is odd. Okay, so first one is we cannot take 7, okay, because there is what? There is no equal sign. Therefore we start with 9, 11, 13 we can include. You see, we have equal sign here, so we can include 13 also. Okay, that's it. You see, sets can be given in this form also. Let's write down a 3 5 0 x a 5. Okay. We have a, then we have b, so 5 0 a, and c and d, so 5 0 x 9. Subset. Okay, A is subset of set B if every element of A is also element of B. Okay, so A is it subset of B. Now we look to the elements of A. 3. Do we have 3 in B? No. Therefore, it is not subset. Now B. Is it subset of A? Okay, so left side we have B here. So every element of B, 5. Do we have 5 in A? Yes. 0, we have. A, we have. You see, every element of B is also element of A. Therefore, it is subset. Okay. So B, is it subset of C? We have 5 in C, yes. 0 in C, A in C, yes. So it is subset. D, A with D. Is it subset? So 3, do we have 3 in D? No. So you don't have to compare the elements. It is not subset. D, is it subset of A? 5, do we have 5 in A? Yes. Next, 0, we have 0. X, we have. 9, we have. So it is subset. B, is it subset of D? So B is, we have 5. Do we have 5 in D? Yes. 0, do we have 0 in D? Yes. A, do we have A in D? No. So it is not subset. Okay? Understand what is subset? Next, we have proper subset. Okay? Set A is proper subset if it satisfies these two requirements. For example, I can write B is proper subset of A because B is subset to A. Here we have checked that. Okay, first one done. Now about this one. Are they equal? Is it equal A and B? No. That means I can write proper subset here. B with C. B and C here. Okay, 5 we have, 0 we have, A we have. So it is subset, but they are equal to each other. B and C. Therefore, I cannot write B is proper subset to C. Okay, understand? That's the difference between subset and proper subset. Okay, in order to be proper subset, it must satisfy two requirements. First, it must be subset. Second, not equal to each other. It's like numbers. 7 is greater or equal 5. I can write like this. Or I can write strictly greater than 5, right? But if we have same numbers like 3, 3, can I write like this? Yes, I can. How about this one? This is wrong. Okay, if I have same numbers, I cannot write 3 strictly greater than 3. It is wrong. Same here. Okay, I can write this between two different sets. If they are equal to each other, I cannot write in. I cannot put this proper subset sign between them. Okay, understand? Let's move on. Okay, for any subset, for any set, okay, there are at least two subsets. The empty set, okay, this one we call empty set A. 5, 7, 9, 10. B, C, and it's 9. So first subset B, is it subset of A? B. So do we have 7 in A? Yes. Do we have 10 in A? Yes. So it is subset. Okay, but A is not subset of B. Okay, be careful with order. So A is not subset of B because not every element of A is also element of B. For example, 5. Do we have 5 in B? No. Okay, therefore A is not subset of B, but B is subset of A. Now, can I put like proper subset here? In order to write like this, it must satisfy two things. First, B must be subset of A, and you have to check another one. B is not equal to A. Okay? In order to write proper subset, you have to check these two things. The first one we have checked here. Okay, it is subset. The second one, not equal. Is it equal A and B? No, it is not equal because in A we have 5, but in B we don't have 5. In A we have 9, in B we don't have 9. Okay, so it satisfies the second one also. Therefore, I can write proper subset. Okay. Okay, so this one we call empty set. Okay, empty set. For any set, we have at least two subsets, the empty set and A itself. So here, for example, we have this set. Okay, find all the subsets. So the first one is from the property, okay, and last one also. And we have two more. We have 7, which is subset of A, and 8 is also subset of A. So total how many? We have 4 subsets. In total, we have 4 subsets of set A. Okay. B. A, B, C. Okay, find all the subsets of this set. So the first one and last one is from the property. Then you can take A itself, B itself, C alone. Okay, then you take combination of AB, AC, BC. So total how many? 8 subsets. Another example, let's say I have 1, 5, 9, 0. I have this set which has how many? 4 elements. Let's list all the subsets. So first one is empty set and C itself, okay, from the property. Then we can take 1, 5, 9, 0. Then you can take two elements, okay, 1, 5, it's also subset of C, 1, 9, 1, 0, and so on. You can take 5, 9, 5, 0, 9, 0. Then you can take the combination of 3 elements. So 1, 5, 9, 1, 5, 0, 1, 9, 0, and so on. Number of subsets. Okay, it is 2 power k, or you can write NA. NA means number of elements. For example, if A is 2, 5, 9, then what is NA? NA is 3. And 2 power NA is 2 power 3, which is 8. So there are 8 subsets of set A. B. So 7, 9, 0, minus 3, 10. NB. What's NB? How many elements? 5. So 2 power 5 is 32. There are 32 subsets of set B. Understand? This is number of subsets. You can easily calculate using this formula. Okay, find the number of subsets for this set. So it consists of x elements. X is a season of the year. So we have 4 seasons. Okay, so there are 4 elements of the set. So 2 power 4 is 16. So there are 16 subsets. Okay, so we call this Venn diagram. Okay, A subset B means A lays inside B. Okay, A is in B. So here we have U. Okay, it represents the universal set. Okay, then here this sign means complement of A. Okay, so it is the elements of U which doesn't belong to A. Okay, for example, let's say U is 2, 5, 9, 15, and A is 2, 9, 15. B, let's say 5 and 9. So complement of A. How to find complement of A? From U, you take out elements of A. So we have 2 here, you delete 2. We have 9, you delete 9. We have 15, we delete 15. What's left? 5. That is the complement of U. Now B complement. So we have 5 and 9. So from U again, you take out 5 and 9. So what's left? 2 and 15. That's the complement of B. Okay? Understand? Easy. Always from U, you just take out elements of A or B or so on. Next operation between sets. Okay, if you take out all the elements, so let's say C is same as U, 2, 5, 9, 15. Then C complement. So you have to take out all the elements. What's left inside U? Nothing. That means empty set. Okay? So here, this is what? Intersection. Intersection means the elements that belong to both sets, to A and B, okay, at the same time. Here, the graph is the middle one here. Okay, the elements which belong to both sets. Or you can say common elements or same elements. For example, A is 2, 5, 9, 15. B is 0, 3, 5, 15, 20. Then A intersection with B means you have to write down same elements, common elements, which belongs to both sets. So we have 5, same, and 15. So I write here 5 and 15. That is the intersection of A and B. Understand? C, 0, 3, 20. So B intersection with C. Now you compare these two sets, okay, B and C. Do you have same elements? 0, 3, and 20. Or it is same as C, so you can write it's equal to C also. A intersection with C. A, C. Do we have same elements? We don't have 0, we don't have 3, we don't have 20. We don't have same elements. That means empty set. Okay? We don't have common elements, therefore it's equal to empty set. This was intersection. Next, okay, A is given, B is given, universal set is given. We have to find a complement of A intersection with B. Okay, first let's find complement of A. So here the U is actually, instead of writing these numbers, they just put dots. That means there is 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is actually U. So we have to take out 3. Okay, we have to take out 3, 6, and what? 9. So the rest you just copy and we get complement of A here. And we have B. So A complement intersection with B will be, do we have same elements? We have 2 here. 2. What else? 4 and 8. So this is the answer. Okay. So one more. Let's find complement of A intersection with complement of B. So let's find B complement first. Okay, so we have to take out 2, 4, 6, and 8. The rest you just copy here. So 0, 1, 3, 5, 7, 9, 10. This is complement of B. Now you compare this one with complement of A, this one. Okay, so do we have same elements? We have 0, 1, 3 we don't have, 5, 5 we have, 7, 9 we don't have, 10. That's the answer. Okay, understand what is complement, what is intersection? Okay, next. A and B are disjoint sets. So if the intersection is empty set, if they don't intersect, okay, then we call them disjoint sets. For example, A is 2, 5, 9 and B is 3, 10. Okay, we have 3 here, 10 here, 2, 5, and 9 here. So we don't have same elements. Okay, so therefore the intersection is equal to empty set. That means A and B are disjoint sets. Okay, we call them disjoint sets. Here definition. Okay, if intersection is empty set, we call them disjoint sets. Okay, union of two sets. So we have two sets. The union means the elements belongs to A or B or both. Okay, so you just copy both sets without repeating same element twice. So A 2 5 9 15 and B is 5 7 minus 3 9 20. So A union B. So we have to unite them. The order doesn't matter. Okay, so you don't have to write in ascending or descending order. So let's copy A first. So we copy A, then we write B. So I should write 5, but I have already. Okay, don't write it twice. You don't have to write it twice. 7, we don't have 7, so I write 7. Okay, minus 3, we don't have, so I write minus 3. 9, I have already. Okay, and 20, I write 20. That's it. Okay, so you just copy both sets without repeating same element twice. That is union. Okay, next. Okay, find this one. So we should find the bracket first. For that we need complement of C. So from U we take out elements of C. Okay, we complement of C. So from U we take out elements of C. So what's left inside? 1. So 0, sorry. 1 is gone, 2 gone until 5. So 6, 7, 8, 9, 10, 11, and 12. This is complement of C. Now we should find B intersection with complement of C. So here we have B, and this one is complement of C. Do we have same elements? So 6 we have, 9 and 12. This is the intersection. Now last step, we have to unite it with A. Okay, this one here, A is this one. Okay, so we have to unite them. So let's copy A first. 1 3 5 7 9 11. Then we copy the elements of this set. So 6, do I have 6 here? No, I write 6. 9, I have already. 12, I don't have, so I write 12. That's the answer. Okay, do you have any questions? Introduction to probabilities. Okay, for probabilities, you have to understand two things. So first one is sample space. Okay, sample space. So for example, you toss one coin. Okay, so sample space, we use letter S, okay, for sample space, and it is all the possibilities. So if you toss one coin, you may get head or tail. Okay, each coin has two faces, head, tail. So it's like som ve gerb or Ariol Reshke. Okay, if you toss one coin, you may get head or tail. Two possibilities. Okay, so that is sample space. Sample space is all the possible outcomes. So if you toss two coins, okay, if you toss two coins, then here, this is all the possibilities. Okay, so you may get head head, head tail, tail head, or tail tail. Understand? If 3 coins, then you get head, 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 tail, tail, head, tail, 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 head, tail, 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 head, and tail, tail, tail. Okay, so how many? Total 8. We have 8 elements. Okay, 8 possibilities, 8 cases. Understand? So this is like subsets. So coin has 2 faces. So 2, if you toss 1 time, it is like 2 power 1. So you get 2 elements here, 2 possibilities. If you toss 1 coin 3 times or 3 coins, that means 2 power 3. That's equal to 8. Here, the number of elements is equal to 8. You see, you can generate that number using the previous formula. So here, how many? You are tossing twice. 2 coins are tossed. So it's equal to 4. You see, we have 4 elements. Another example, 1 die. Sorry, it is die if it is 1. If more than 1, then we call dice. Okay, 1 die. It's what? Zarik. Okay, this one. Okay, what's sample space? So 1, 2, 3, 4, 5, 6. Okay, if you toss a die, you may get 1, 2, 3, 4, 5, or 6. If 2 dice, then it will be more. So each die has how many faces? 6 faces. 6 power 1 gives you 6. So here, number of elements of sample space is equal to 6. If 2 dice, 6 power 2 will be 36. Okay, if 2 dice, then how many? There are 36 possibilities. If 3 dice, 216 possibilities, and so on. Understand? So did you understand what is sample space? This is the most important thing, okay? The most important one. You should find sample space, and from there you will get these events. Okay, next one is events. So events. Event E, F, G, H. You can use any letter, okay? Only S is for S stands for sample space. For event, you can use any letters. Okay, so write the event E. The coins show exactly 1 head. Okay, so which one has exactly 1 head? Here 1 head, here 1 head. This one has 2 heads. Okay, so you cannot take this. This one has no heads. So event E is equal to head tail or tail head. Understand? Another event, same face. That means which one has same face? Head head, and tail tail has same face. G. Okay, they may ask, what is if you toss 2 coins, what is the probability of getting same head? So getting same face, I mean. Getting same face is event. Okay, tossing 2 coins, from there you get sample space. So G, at least 1 head. Okay, what's the probability of getting at least 1 head? Then we have event there. At least 1 head. Which one has at least 1 head? Head head, head tail, tail head. This 3 has at least 1 head. That is event. Okay, Understand? Oh, if it's about one die, sample space is 1, 2, 3, 4, 5, 6. And let's say they ask find the probability of getting odd number. So that means odd numbers are 1, 3, and 5. That's H. Okay, that is event. Next. Okay, so set operations. So between sets you have intersection, union, and complement. Here also you see the events and sample space are just sets. So here also you can use same operations. So but the intersection here means and, okay, which when E and F event occurs at the same time simultaneously. The union means or, when event E or F or both. Complement means the opposite, okay, when E doesn't occur. If an intersection is equal to empty set, then we call them mutually exclusive events. For example, one die, okay, getting 3 and 5. This is AND. Okay, that gives you empty set. Getting 3 and 5. If you toss once, you cannot get two different numbers at the same time. Okay, so getting 3 and getting 5, these two events are mutually exclusive events. Understand? If intersection is empty set, we call them mutually exclusive events. Okay, so this is the first formula for probabilities. Okay, so you see we need to find number of elements. We need NE and NS. So I want to toss a coin. Okay, one coin. What is sample space? You toss one, then you may get head or tail. Okay, you can get head or tail, Ariel or Reshke. Okay, so they ask what is the probability of getting a head when you toss a coin. Okay, when you toss a coin, okay, or one coin. So first you should find sample space, that is all the possible outcomes. So if you toss one coin, you may get head or tail. Then the event, the probability of getting head. Okay, so the event is about getting what? Head. Understand? Understand the sample space and event? Now, to use this formula, we need NE. NE is one number of elements. We have one element here. And NS, here, how many elements? HT, we have two elements. So if you substitute to the formula, you get 1 over 2, that is 0.5. So the probability of getting a head when you toss a coin is 0.5. Understand? Or you can say there is 50% chance to get head. Understand the example? Okay, next one. Next one. One die. Okay, Zarik. Okay, probability of getting Probability of getting, let's say, even number. Okay, you toss a die. So how many faces we have? 6. You may get 1, 2, 3, 4, 5, and 6. Okay, if you toss a die, you may get 1, 2, 3, 4, 5, 6. Getting even number. So the event is about getting even number. How many even numbers we have here? 2 is even. Okay, juft. You know odd and even is like juft and talk, or chutney and tin chutney. Okay, so 2, 4, 6. Now we use this formula. PE is equal. It was better to use F here because we have E already. Let's make it F. Doesn't matter. Okay, PF is equal NF divided by NS. So how many elements in F? We have 3. NS 6. So that is 6 over 3 over 6, which is 0.5 again. Okay, so the probability of getting even number is equal to 0.5. Understand? Let's see another example. May I clean this? Okay. 2 coins. Let's toss 2 coins. Okay, and find the probability of getting at least one tail. So 2 coins, if you toss 2 coins, you may get head, 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 tail, tail, head, or tail, tail. Okay, we have 4 possibilities. So now the event, at least one tail. So which one from S? Okay, you choose the elements which has at least one tail. This one has at least one tail, this one, and this one. So it is head, tail, tail, head, or tail, tail. This is sample space S. G is event. Okay, and S is 4, and G is equal to how many elements? 3. So Pj is equal Nj over Ns. That is 3 over 4, or 0.75. So probability of getting at least one tail is equal to 0.75. Or there is 75% chance that you get one tail, at least one tail. Okay, understand? Okay. Okay, here. Suppose a single fair die is rolled. Use the sample space. So if one die, okay, single die, then sample space will be 1 till 6. Find the probability of die shows a number less than 5. Less than 5 means can be 1, 2, 3, or 4. So you use the formula, okay? So NH divided by NS. NH, how many elements? 4. S has 6 elements, 2 over 3, or approximately 0.67. There is 67% chance to get number which is less than 5. Okay, the probability of getting 5. How many 5s we have? Only 1. Total 6. So it is 1 over 6. Okay, so the price per lamp is 5,000 soms. Okay, each lamp you sell for 5,000 soms, but you want to add 3 years warranty. One interesting question: what's the probability of getting a car among 3,000 volunteers during a day? 1 over 3,000. Okay, so you want to give 3 years warranty. Okay, then first what you do, if you just sell at the same price 5,000 soms, then you will lose. Okay, you will be in loss because you have to replace the lamps that are burnt or dead, okay, in 3 years. Therefore, what you do, you have to increase the price. For that, you have to make a simulation. So you take 1,000 lamps. Okay, you take 1,000 lamps. It's sample. Okay, you take 1,000 samples and you switch them on for let's say 3 years. In 3 years we have 365 days. Okay, each day how many hours you use a lamp? Approximately, let's say 8 hours. Okay, we use each lamp for we turn on the lamp for 8 hours daily. Okay, approximately. So you get 3 times calculator, 3 times 365 times 8, you get 8,760 hours. So that means each lamp, okay, will work approximately 8,760 hours in 3 years. So you take this 1,000 lamps, you switch them on for 8,760 hours. Okay, after this much, after that time, okay, it's approximately it's equal to 1 year. So after 1 year, you count the lamps that are dead. Okay, let's assume, okay, we don't have time to wait such long, so let's assume, so 200 dead, okay, or burnt. 200 lamps are dead in 8,760 hours after. So now you can find the probability. 200 divided by 1,000 gives you 0.2. Okay, and that is 20%. Okay, so you should 20%, approximately 20% of your lamps will be dead in 3 years. So you have to replace them. Okay, so you will lose money. Therefore, you have to increase the price. So new price. You should increase it. Okay, you should. It is actually 100%, but you should increase it at least by 20%. So I can multiply it by 120%, which is 1.2. So you get 6,000 soms. Okay, this is new price. So after this study, after waiting 1 year, you can increase the price from 5,000 to 6,000 and give 3 years warranty. and you don't lose anything. Okay, you lose nothing. So, total cards, how many cards we have? 52. Okay, total number of cards is equal to 52 here. Then we have how many reds and blacks? The half of the cards are black. Okay, so 26 black cards and 26 what? Red cards. Then we have heart, diamond, the club, and spade. How many pieces? 13. Okay, this is heart, this is club, this one we call diamond, and this one spade. Then we have face cards, face or picture. How many? 12. You see this face cards. It is jacks, queens, and kings together. 3 times 4 is 12, so there are 12 face cards. Then we have ace, 2, 3, 4, okay, 5, and so on. Queen, king. Each how many? 4 pieces. Okay, here you see we have 4 ace, 4 twos, 3s also have 4 pieces, 4 jacks, 4 queens, 4 kings, and so on. Okay, you have to remember these numbers. Okay, you have to remember these numbers. So total, we have 52 cards, half of them black, half of them red. Okay, quarter of them are diamonds, quarter hearts, and so on. So what's the probability? Okay, so we take one card, okay, without seeing it. So what's the probability of getting king? Okay, how many kings we have here? Okay, we have 4 kings out of total cards 52. Okay, if it's about cards, then NS will be 52. Okay, probability of getting king, choosing king, is 4 out of 52. So 4 divided by 52 is 0 points, approximately 0.8. Okay, there is 8% chance to choose a king when you take a card from desk of cards. Okay, probability of drawing jack or king. So probability of jack or king. So how many jacks we have? 4 jacks. How many kings? 4 kings out of 52. So it is 8. I have already here. 8 over 52, or 2 over 13, or if you divide 2 by 13, you get 0.15. Okay, probability of getting, let's say, black cards. How many blacks? 26 out of 52, so it's equal 0.5. Probability of choosing heart. How many hearts? 13 out of 52, or 0.25. Probability of choosing black queen. How many black queens? Okay, this one, queen spade and queen club and queen spade. Okay, we have 2 out of 52. Okay, you have to remember these numbers. Do you have any questions about cards? Then let's move on. Okay, so probability is always between 0 and 1. Okay, it's always between 0 and 1. If you get negative value or the value which is greater than 1, then you have mistake. Okay, check your answer again. So formula number 2, we call it union rule. Okay, now it's about two events. Now it's about two events. So you have to remember this formula. Okay, if a single card is drawn, okay, from ordinary deck of cards, find the probability of an ace or club. So probability of ace or club. Now we use union rule here. So PEF is equal to what? PE plus PF minus PE intersection F. So E, this is OR. This one is AND. Okay, we use this union rule formula. Then for each we can use the first formula, PE what? NE over NS. So we can write NE over NS plus, instead of PF we can write, sorry, it's not EF, it's ace and club. So ace club, ace club, ace. Okay, ace. How many ace we have? Ace is 2. We have 4 out of 52 cards. Clubs. How many clubs we have? 13 out of 52. Minus ace club. Do we have ace club? Okay, ace club. Do you have such cards? Okay, ace and club at the same time? Yes, we have only 1. Okay, we write minus 1 over 52. So 17, 16 over 52. And it's approximately, so 16 divided by 52 is 0.31. Do you have any questions? Okay, do you have any questions? No? Okay, this is the ace, ace, okay, ace. How many aces? We have 4 aces. We're counting this. And when you count clubs, you count this again. We're counting this twice. Therefore, we have to subtract one of them. Okay, ace club. This is ace and club at the same time. Therefore, we put 1 here, and the answer is 16 over 52. Okay, so so you can buy cards to study. Okay, don't Don't buy this to play. Okay, only study purpose. Okay. Find the probability of getting king or heart or red. Let's say red. So P king, PR red minus king red king. Okay, kings. How many kings we have? 4 out of 52. Red cards. How many red cards? 26. Red kings. How many red kings do we have? Where's the red king? Red king. The king heart and king diamond is red. Okay. Here, king. Yes. Okay. These two. You see, king heart and king diamond. 28 out of 52. So approximately 54. The probability of getting heart or what? Black. P heart, P black minus heart and black. So how many hearts we have? 13. Black cards 26 minus black hearts. So all the hearts are red. Okay, so there is no black heart. That means it is 0. Or you can say this two is mutually exclusive events. Okay, so 39 over 52, 75. Okay, understand? Okay, 2 dice. Okay, 2 fair dice are rolled. So if 2 fair dice, then I recommend you to to make this table first. And S equal 36. Okay, there are 36 possibilities here. So for example, 2 5 means you roll 2 dice. Okay, 2 Zarik, 2 dice, and you got 2 here, and another one 5. Okay, first die shows 2, second one 5. That means it is 2 5, and so on. So you may get until 6 6. That means how many? If you count 1 2 3 4 5 6 7 and so on, then you get 36. Okay, so number of sample space, number of elements of sample space is equal to 36. So NS is equal 36. Okay, I recommend to make this table. So find the probability that sum is 8 or both die show same number. Probability of sum 8 or both same. Sum 8 plus P same minus probability of getting sum 8 and same. So now denominator will be 36 because there are 36 possibilities. Okay, sum 8. Which one sum is 8? Here. 6, 2, 5, 3, 4, 4, 3, 5, and 2, 6. Okay, if you add them, you get 8. So how many? 5. Plus. Both same. Okay, it is not 5. This is S. So same. How many same? So here, 1, 2, 3, 4, 5, 6. So we have 6 elements. Minus, at the same time, sum must be 8 and must be same number. Here, only 1. You see the intersection? We have 4, 4. So only one element. So 5 plus 6, 11, 10 over 36. Let's see, approximately 10 over 36, 0.28.